In this video, we'll talk about atoms and elements. What are atoms, what are elements, what are symbols, etc. So we'll begin firstly with elements. We have already talked about elements in the previous chapter and the previous videos. So elements are pure substances from which everything else is built off. So every substance that you see is basically composed of either a pure element or a combination of different elements. And elements cannot be further broken down into any simpler substance. All the elements that exist are composed of a unit which is called an atom. An atom is basically the smallest particle of the element that retains the properties or the characteristics of that particular element. For instance, aluminum foil, when you think of, is composed of atoms of aluminum. So atoms are basically the smallest particle of an element that can retain all its properties. And when you talk about elements, another thing that you would very commonly see in chemistry is symbols of elements or symbols of atoms. What are symbols? Symbols are basically just abbreviations that are used for describing different elements. Usually these abbreviations are one word, which or they can one letter, or they can be of two letters. They always start with a capital letter. If the first letter is always going to be a capital letter, and if it has two letters, the second letter is always going to be a smaller letter. Okay. For instance, you would see elements like carbon can be abbreviated as capital C, nitrogen, capital N, fluorine, capital F, oxygen, capital O. So these are one letter symbols for some of the elements. If you're looking for elements with two letter symbols, you'll see elements like cobalt, where again the first letter is written in capital, followed by the second letter, which is written in small. So cobalt is written as CO. Calcium is written as Ca. Again, C is capital and A is small. Aluminum is written as Al. Magnesium is written as Mg. Now these names and the symbols of the elements you will have to familiarize yourself with because you'll see them coming up very commonly in rest of these chapters. So make sure you familiarize yourself with the naming and the abbreviation of different elements. Some elements are named like this. They are named based on certain planets, minerals, colors, locations where they were found. For instance, there's an element like uranium, whose symbol is U, titanium is Ti, chlorine is Cl, iodine is I. So basically you should familiarize yourself with all these symbols and the elements that they represent. Some of the elements are very easy. For instance, aluminum is abbreviated as Al. We saw element like carbon, which is basically abbreviated as capital C. Chlorine is written as Cl, right? Cobalt is very simple, the first two letters written as Co. Some of the elements, on the other hand, are a little difficult. They are not exactly written as their they don't match. The name and the symbol does not really match. That is because those symbols are based on their older names or their Latin names or their Greek names. Okay, for instance, gold. You will not see the symbol of gold as GO. Instead, it's written as AU. That AU symbol is basically coming from its Latin name, which is aurum. Similarly, iron. When we talk about iron, the symbol that is used for iron is Fe. That comes from its Latin name, which is ferrum. Same thing with lead. Lead is written as Pb or abbreviated, or the symbol is Pb, which comes from the word plumber. Okay. Same thing with mercury. Mercury is written or abbreviated as Hg. So there are some names which are not very obvious when you look at their symbols. So you should definitely be familiar when you see these names. You should know that, okay, if I see Au, that means I'm looking for gold. Hg stands for mercury. Cu stands for copper. And Co stands for, where was it? Co stands for cobalt. Okay, so there are some names that are very obvious, but some names which are a little different and not as obvious as the others, right? For instance, nitrogen is N, nickel is Ni, neon is Ne. Very simple. It's just the first two letters or the first letter of their name. Oxygen is O, phosphorus is P. So some of these elements are very easy, but some are not. Like potassium is capital K, has nothing to do with the name potassium, but its older name, right? Silver is written as Ag. Sodium is abbreviated as Na, as you will not find N or A in the word sodium at all. Okay, so this is something that you should familiarize yourself with. Tin is Sn. Rest, most of these symbols are very easy to remember because they come from the actual name. So make sure you read through these names and repeat these names and these symbols every now and then so that you're more familiar with the naming and the elements and the symbols later on when we talk about the later chapters. Okay. Okay, so that was all about the elements and the chemical symbols. Okay, next thing we'll talk about that you might have probably seen a lot in chemistry is periodic table. So a periodic table basically is this. What you see right here, it is arrangement of all the elements that exist. These have been arranged into different groups. They have been placed in an increasing order. So you can see right here, they have been placed in an increasing order of their atomic mass. So we'll talk about what is atomic mass and what is that, what all these terminologies mean, okay, as we go through this chapter. But essentially, this is how your periodic table would look like. Each of these elements that you see is a different element, different atom, and there are a bunch of numbers usually written out on a periodic table. So now we'll try and understand what exactly these numbers mean. Okay. So a periodic table is divided into columns and rows. These are referred to as groups and periods. So groups essentially are the vertical columns. The columns that you see in a periodic table are called as groups, and the horizontal rows that you see in a periodic table are called as periods. Okay. So this is a periodic table. This is how a periodic table would look like. You probably have seen this a bunch of times. So a periodic table is basically arrangement of the elements in groups and columns and rows. Okay, these groups right here are the name of the columns. Sorry, let me grab my pen. So this, what you see right here, are the group numbers. These are the column numbers. So essentially all the columns that you see, 1, 2, 3, 4, 5, 6, these are called the groups. There are 18 groups, you can see 1 through 18. This is group 1, 2, 3, 4, 5, 6, and then followed by all the other groups, and the last group that you see on a periodic table is 18. So basically it has 18 columns, meaning 18 groups. Another thing that you would see in a periodic table are the rows. Each of these rows are referred to as periods. So what you see right here, a periodic table consists of total of 7 rows, so it has 7 periods. So for instance, period number 1 has hydrogen and helium in it. Period number 2 starts from lithium. It has basically lithium, beryllium, boron, carbon, nitrogen, oxygen. This whole row is period number 2. Then similarly we have a total of 7 rows, meaning 7 periods. Another thing that you'll notice here is this part right here on the group number. You'll see sometimes it's written as 1, 2, 3, 4, 5, 6, 7, 8 to 18. And another name that is usually given to the groups is 1A, which is 1 followed by an alphabet A. So this is 1A, this is 2A, this is 3A right here, 4A, 5A, 6A, 7A, 8A. Whereas everything here in the middle is referred to as a number followed by an alphabet B. So this is basically group 3, but it is 3B, 4B, 5B, 6B, 7B, and everything basically in the middle is a B. Everything up top here are A's. So what are these A's? Everything in which has a group number or name as an A is called representative element, or this is also referred to as the main group elements. Okay, these are the main group. These are also called as the main group elements of a periodic table, or the representative elements. You should memorize these names or familiarize yourself with these names on a periodic table. Okay, these are basically just the names given to groups so that you don't have to remember every single element every single time. If I'm saying I'm talking about group number 1, sometimes it's difficult to remember 1, 2, 3, 4. Some groups are given different names, okay, based on their properties. So now you'll see those names. So basically, if you are trying to divide the periodic table, these two first groups and these following last groups are called as representative elements or main group elements. Okay, and everything right here in the middle. Oh, okay, there we go. So right here, whatever you see in the middle, this right here is referred to as the transition elements of the periodic table. This middle portion is called the transition elements. What you see right here is an extension of the periodic table which comes from here. You see right here, this is called LA. This is the lanthanide series. You see this is 57, and then it starts with 58, 59, 60, 71, and then 72 starts right here. So basically this everything right here that you see is belong to the lanthanide series, and that's where the name comes, lanthanides. And the second one that you see right here is the actinide series, which basically starts right after this particular element AC. This is 89 followed by 90, 91, 92 until 103, and then it comes back to this, which is 104. Okay, so all this in the middle along with these two are transition elements. Okay, moving on, this group number 1A that you see is also called as the alkali metal group. Okay, everything in this group except this hydrogen is an alkali metal. Okay, these are all the metals. These are called alkali metals. Group number 2 or 2A is also called as alkaline earth metals. Why are they given these different names? Because of their properties. So this group, everything in this group behaves very similar to each other. They have very similar chemical properties, and that is why they are given these group names. Okay, these are just the common group names that are given to some common existing elements because of their properties. So these are called as alkali metals. These are called as alkaline earth metals. We'll talk about their properties and everything later on. Next is this group 17, which is also referred to as halogens. Okay, everything here, fluorine, chlorine, bromine, iodine, all these are basically halogens. And the last group is called as the group number 18, or sometimes it's also called 8A, is called the noble gases. These are also called as inert gases sometimes. These are noble gases or inert gases because they are inert, meaning they do not like to react with anything. They are happy in their own world. They are inert, meaning they do not react with anything else. They are the least reactive elements on the periodic table. Okay. All right. So, next thing you should also see in the periodic table is these colors. These colors signify something. So everything else, everything in this periodic table that you see in blue is a metal. So most of the left side of the periodic table, remember that, okay? Most of the left side of the periodic table is metals. So you can see right here, everything here is metallic in nature except this hydrogen, okay? Everything on the far right side of the periodic table, so far right of the periodic table is a non-metal. So we'll see what metals and non-metals mean. You probably are familiar with that, but we'll go over that again a little bit in the next few slides. But everything on the far right is a non-metal. Everything in the middle that you see right here along this black darkened zigzag line in green is a metalloid, meaning it has the properties, its properties are in between metals and non-metals. Okay, metals are basically like iron, right? That's a metal. Copper, that's a metal. So metalloids are basically, they have properties somewhere in between metals and non-metals. They're not exactly metals and they're not exactly non-metals. Okay. So what you see right here in green along this zigzag part of the periodic table is called the metalloid. How can you expect questions from this? Basically, I can just simply ask you, oh, CR. Is it a transition element? Is it representative element? Or which group does it belong to? Which period does it belong to? So CR is right here, chromium. It's a transition element. First thing, it belongs to group number 6B and it belongs to period number 4. Okay. So you should be able to identify different elements when you look at the periodic table. Based on that, you should be able to identify, is it a metal, is it non-metal, is it a metalloid? Okay. Okay, so whatever I just told you is all written in the slide in words for you. So you can go back and look through the slide, read through the slides, and it would give you the same information that I just told you. Okay, and this is another breakdown of the periodic table, which shows you these everything right here. Up top is the representative elements, in the middle it's transition. These are alkali metals, alkaline earth metals, halogens, and noble gases. In this group in the middle really doesn't have a common name. Okay, this is alkali, alkaline earth metals, halogens. So halogens are basically very highly reactive, and they form compounds with most of the elements. Okay, for instance, you might have heard of the compound called sodium chloride. Again, if you don't know much of it, it's fine. We'll see more and learn more about this later on. But basically, there's a very common compound which is called sodium chloride, which is written as NaCl. This is the salt that we usually consume. So most of the compounds, this right here, is composed of one metal, which is sodium, and one non-metal, which is Cl. So non-metals essentially are very highly reactive. You'll see that most of the times non-metal will come more familiar in a lot of compounds that you see. Okay, so here are some of the questions that you guys can practice on your own. For instance, very simple, group 7a, identify the element described by each of the following groups. So like, which element out of these belongs to group 7a, period number 4, okay? So you can go to periodic table, you should know what period means and what group means. And then you can identify which of these three actually belongs to period 4, group 7, okay? So for this, you need a periodic table handy to yourself. Okay. Next, I also explained to you this zigzag line that you see up top. In the periodic table, everything basically is a line that separates metals and non-metals, and whatever is next to this is regarded as a metalloid. Okay. So metals, except for hydrogen, are located on the left side of the periodic table. Metals are what? They basically are shiny, they are ductile, they are conductors of heat and electricity, meaning they'll let the electricity and heat pass through them. Ductile means that you can like bend them and turn them into like wires and stuff, right? They are solids except for mercury, which is a liquid. Mercury, remember, is filled up in thermometers. So mercury is the only metal that exists as a liquid. Then non-metals are located on the right side of the periodic table. They are dull. Dull means they're not shiny. They are brittle, meaning they can easily be broken apart. So they are not ductile. So if you hammer on them, they are easily going to break. They are poor conductors of electricity, but they are good insulators. So they're poor conductor of electricity and poor conductor of heat. And sometimes they are just like non-conducting. They don't conduct heat, they don't conduct electricity through them. They have low density and they have high melting points. And metalloids, on the other hand, they exhibit the properties of both metals and non-metals, right? So they are basically somewhere in the middle. They are um, better conductors than non-metals, but they're not as good as metals, right? So they're in between metals and non-metals. They're also called as semiconductors. So semiconductors is something that you might have heard very commonly used in most of the chips, right? And they are also very good insulators because again, they are not as conducting as the metals, okay? So here you can see some of the properties of metals, non-metals, and a metalloid in between. Okay, so you can compare their properties and see how metals and non-metals and metalloids are different from each other. Okay. All right, some questions. Again, you guys can go back and practice through these questions on yourself. They are fairly simple and very direct. Next, we'll talk about atoms. So uh, we'll try to define an atom. What's an atom? What is the shape of an atom? What does it consist of? What exactly is an atom? So first theory that was given regarding the atom was given by Dalton, It's called the Dalton's atomic theory. So, what did Dalton tell us? He developed an atomic theory, and he proposed that atoms are the ones that are basically responsible for combination of elements and compounds. So, atom is anything that will basically compose elements. Okay, what does this theory tell us? Most of the stuff you're already familiar with. Um, Dalton told us that, or according to his theory, all the matter is made up of tiny particles that are called atoms, first definition. Secondly, he mentioned that all the atoms of a given element are identical to one another and different from the atoms of other element. That essentially means if I'm talking about, let's say, aluminum foil, right? Aluminum foil will be always composed of atoms of aluminum. Okay? And all these atoms that are present in there of aluminum are similar to each other, are identical to each other, and these atoms are completely different. For, let's say, if I'm talking about copper now, if I have a metal copper, copper will be composed of all atoms of copper. So copper atoms are going to be completely different from aluminum atom, right? Next, according to this theory, atoms of two or more different elements combine to form compounds. And a particular compound is always made up of same kinds of atom and same number of each kind of atom. This is very similar to the definition that we saw uh, previously in the previous chapter of a compound, right? So for instance, if I say I have a compound sodium chloride, like I told you. So according to this theory, sodium chloride is a compound which is composed of different atoms of sodium and chlorine, which is correct. And when you have this compound, you can take this compound from wherever in this world, it will always consist of one atom of sodium and one atom of chlorine. So it will always consist of the same number of each kind of atom. That's exactly what this theory told us. The next proposal of this theory was that a chemical reaction involves rearrangement, separation, or combination of atoms, and atoms are never created or destroyed in a chemical reaction, which also holds true. So essentially, if you have a chemical reaction going on there, the atoms are never broken down. So for instance, if there is a reaction between let's say something with sodium chloride, you cannot just simply convert sodium into a different element. Okay, sodium will stay as in product, also it will stay as sodium, and chloride will stay as chloride or chlorine atom. So basically you cannot change the identity of the atom during a reaction. Only thing that happens is a rearrangement. Okay, so for instance, sodium might just now, instead of being with Cl in the product, it might just interact with something else. Okay. Next thing, before we try to understand the composition of an atom, we should be more familiar with the charges, electrical charges. And something that you should probably know is, or you might have heard of this before, which is opposites attract and likes repel, right? This holds true when we're talking about charges. Yeah, this can be used in a lot of different ways to describe a lot of different things. But in our case, we are basically focusing on charges. So opposite charges attract each other and like charges repel each other. That essentially means that if I have something which is positively charged, if I bring it close to another positive charge, that is going to repel. The two positives are going to repel each other. Similarly, if you bring two negatively charged objects closer to each other, they are going to repel each other and try to be away from each other as much as possible. And if you try to bring unlike charges, for instance, if you have a positively charged object and a negatively charged object, they are going to basically attract each other because opposite charges attract each other, so they will try to be closer to each other because of the force of attraction. So opposite charges attract and like charges repel each other. Okay. Now, using this information, so in order to understand the structure of an atom, J.J. Thomson, a physicist, did an experiment. So he basically had a glass tube and ran electricity through that tube such that it produced some rays. And then these rays were passed through two electrodes. One was a positively charged electrode, another was a negatively charged electrode. Okay. So these rays, basically, he noticed in his experiment that these rays were deflected more towards the positively charged electrode, which means that these rays, because they were attracted towards positive charged electrode and repelled by negatively charged electrode, he said that these rays were negatively charged and called them cathode rays. So based on this experiment, he said that an atom basically is composed of negatively charged particles, which are really small, and they are called as electrons. And the other scientists, they knew from beforehand that atoms are neutral. Okay, so they knew that atoms have no charge. They are neutral in when it comes to charge, which means that if they are composed of something as electrons, they definitely have something else inside of them which is neutralizing this charge. So scientists soon said that it consists of another particle inside an atom which is called protons, and these protons must be positively charged, right? So they basically proposed, based on these, following this and following few experiments, they proposed that an atom consists of two components. One is an electron, which is really small, it is really light in weight, and the second is component is a proton, which is positively charged and is much more heavier in weight. And they basically, based on these experiments, Thomson came up with a model for the structure of an atom, and he said that atom is basically like a plum pudding, where the protons are more like a cloud. They are positively charged cloud distributed throughout the space of an atom, and then the electrons are basically like plums. These are the negatively charged particles that are randomly distributed inside this positively charged cloud. So basically, an atom is mostly hollow, and at some points, it consists of electrons, right? And now to confirm theory, confirm this theory, Rutherford did a few experiments along with Thomson, and these experiments are referred to as the gold foil experiment. So what he did here is essentially he had a positive stream of positively charged particles. So he had a beam of positively charged particles. So these particles are positively charged. He took this and he tried to pass them through a very thin foil of gold. Now, if Thomson's model was true, then most of these positively charged particles will just travel in straight line through the gold foil. So they'll just go straight through the gold foil, because based on the plum pudding model, uh, most of this is hollow, right? But what he noticed is that most of these particles, the beam that he passed, they some of them passed through the foil, but most of them were deflected through the gold foil. Deflected, so that some of them essentially just came back. Some of them were deflected at an angle for like this. Some of them were deflected at an angle. Some of them were completely came back or returned in the opposite direction. So based on his experiments, he realized and concluded that an atom consists of a very small positively charged region in the center of the atom, and he called this as nucleus. And he proposed that electrons in the atom occupy the space that is around the nucleus. And most of these, this was the region where most of the particles basically just traveled through the atom. For instance, like this, some of the undeflected some of these gold, the beam that he passed through the gold foil, some of this was undeflected, right? So he said these that were undeflected, they were just passing through the empty space, and whatever you see in the middle that was deflected back, those are the particles that came across the center of the atom, which is a dense nucleus. Okay. So So based on his experiment, he concluded that an atom basically consists of a very dense center, which he called as nucleus, which consisted of the positive charged particles, which is protons, and then on the outside space surrounding this nucleus are electrons. Okay, this was occupied by electrons which are negatively charged. But then there were some more experiments performed by other scientists, and they realized that the mass of the nucleus was not equal to the mass of the protons. the mass of the nucleus was much heavier than the total mass of the protons that were inside of it, which because of which they came up with they discovered they knew that there was some other particle that was present inside the nucleus along with protons, and that's when with few more experiments they discovered another part of the nucleus which is called neutrons. So now, based on all these experiments, we can say that the actual structure of the atom looks something like this, where it consists of a very dense nucleus, which is positively charged. So nucleus is positively charged. Why? Because it consists of positively charged protons and neutrons, which are neutral. So neutrons are neutral in charge, but these are heavy. Similarly, protons are positively charged. They are also heavy, and they too combine together to make up the mass of the nucleus, which is the most densest part of the atom. And then on the outside, most of the space is occupied by electrons which are negatively charged. But the mass of the electron is very, very small. It's a very smaller mass in comparison to the whole atom. And sometimes the mass of the electron is also regarded as negligible. You could even disregard. So the mass of the atom is due to the mass of its protons and the neutrons combined in the nucleus. Electrons have a much smaller mass. So because the mass of an atom is really small, usually chemists refer to it as atomic mass unit, or abbreviation usually very commonly used is AMU. AMU stands for atomic mass unit, meaning mass of one atom. And how is this mass defined? The mass of this one AMU is essentially equal to 1/12 of the mass of the carbon atom. So mass of the carbon atom is essentially 12. If you look at the periodic table, its mass is 12. And carbon atom consists of 6 protons and 6 neutrons. So basically in total it has 12 particles, right? So what would be the mass of one particle? Mass of one particle would be 12 divided by 12, which is 1. So that is defined as 1 AMU, which is mass of one carbon. So therefore it's called 1/12 of the mass of the carbon atom. Okay? So mass of one proton is equal to 1 AMU. To be exact, it is 1.007. Mass of one neutron is also 1 AMU. To be exact, it's 1.008. Mass of an electron, you can see in comparison to these, is much smaller, it is 0.00055 AMU. And that is why mass of the atom is usually neglected. It is regarded as negligible in mass. Another unit of mass that you will very commonly see being used in biology is Dalton. So 1 AMU is regarded same as 1 Dalton. This is just another unit which is commonly used in biology. So this is a summary of all the subatomic particles that are present in atoms. Subatomic means present in an atom, smaller than an atom. So an atom consists of protons and neutrons, and these two basically make up the nucleus of an atom. And the symbol of proton is a small p, or sometimes it's also written as p plus. Plus essentially means it's a charge. It has a positive charge. And most of the times, whenever you see a charge written on an atom or on any particle, it's usually written as a superscript on the right side. Okay, so if you see something written like X and on the right something is written as a superscript, that means we are talking about the charge of that particular uh, element, object, atom, whatever you want to call it. Okay. So this is what is commonly used in chemistry, physics. So whenever you see something written up top there, that means we are talking about the charge. So in case of a proton, we know it carries a positive one charge, so therefore it's written as plus. If no number is written, that means it's a 1. Okay, so it has a charge of +1. This is the mass. Where is it located? It's in the nucleus, right? Protons and neutrons inside the nucleus. A neutron is usually abbreviated, or the symbol is N or N0. Zero essentially means it has zero charge. It is neutral. The mass, and then it's also located in nucleus. Electrons are abbreviated as E, small e, with a charge of -1. So an electron has a negative charge. This is the mass. It is located on the outside of the nucleus. It occupies the mass or the space outside of the nucleus. Next thing you'll see very commonly used is an atomic number. So here are some definitions that you should familiarize yourself. The atomic number essentially is equal to the number of protons in an atom. This is very important. Atomic number stands for the number of protons that are present in an atom. This is specific to an element. So if we are talking about any element in the periodic table, it will always consist of a certain number of protons. That never changes. Okay, which means if I have an element, right here you can see this is the symbol of sodium. Atomic number of sodium is 11. So let's say I found an atom, I don't know what its name, and I somehow did an experiment and figured out that its atomic number is 11, which means I know that it has 11 protons. So if I know that atom has 11 protons, I know I can identify that atom as sodium. Okay, so every sodium atom to exist would always carry 11 protons or would have an atomic number of 11. So basically atomic number tells you the identity of the element. The atomic number is specific for each element and that is equal to the number of protons. Okay, where would you find this number usually written? On the periodic table. So in periodic table you would see these numbers written up top right here. In each box along with each element, that essentially means we are talking about its atomic number. So atomic number of oxygen right here, O, is 8. So it consists of 8 protons. How many protons does bromine carry? Bromine is Br right here. It has 35 atomic number, which means bromine atom, wherever you find it, will always carry 35 protons. How about sodium? Sodium is right here in the periodic table, 11, which means it has 11 protons. Okay, calcium, right here, Ca is calcium. It has 20 protons. Why? Because its atomic number is 20. Okay. So here are some more examples that you'll see in your slide in your periodic table. So you should be able to solve for this. Okay. Next thing I told you guys before is that atoms are always neutral. Okay. When we talk about any atom, you'd see on your periodic table, all the atoms are neutral. Whenever an atom has a charge, it would always be written out as a superscript on the right side. If you look at your periodic table, none of these atoms have any charges on them. It means all the atoms are neutral. So if atoms are neutral, that means protons carry a positive charge, each electron carry a negative charge. So one proton will cancel out charge of one electrons. So if I talk about sodium, how many protons does it have? We just saw that sodium has 11 protons, which means it has a total positive charge of 11. And since sodium is a neutral compound, you don't see a charge written out here, right? Which means it is 0, which means it also should consist of negative 11 negatively charged electrons to cancel out the 11 positive charge that it has, which means the number of protons will be always equal to the number of electrons as long as the atom has no charge. Slowly later on you'll see that sometimes with the symbols you might see some charges up top on the right. That is called an ion. Then it's no longer an atom. If an atom has a charge, for instance, sodium can be written as Na+, then that means that if it is Na+, it's not an atom, it's an ion. Okay? Na+ means it has +1 charge, which means, we'll talk about that later on, which means, but this is no longer an atom. If you're talking about an atom, the charge would be neutral. So number of protons will always be equal to number of electrons in an atom, as long as the net charge is 0. Okay. So kind of question you can expect is right here, sodium. If this is the element sodium, can you figure out what is the atomic number, what is the number of protons, and what is the number of electrons? Let's pick two examples. Let's do sodium and zinc. Zn stands for zinc. How can you figure that out? You need a periodic table for that. So if you go to periodic table, you look for the element sodium, which is Na right here. How many protons does it carry? You will look for the atomic number. It has 11 atomic number, which means protons is 11. What is the number of electrons here? It is neutral, which means protons and electrons would be same, so it has 11 electrons. The next thing it was asking, what was the atomic number? Atomic number is 11. The next example that the question had was zinc, right here. Zinc is Zn, present right here in the periodic table. Based on this, I can say that what is the atomic number? Atomic number is 30. What is the number of protons? Protons will be equal to atomic number, which is 30. What is the number of electrons? Again, no charge, which means number of electrons is equal to number of protons, also 30. So basically, you can just look up the periodic table and figure out protons, electrons, and the atomic number. Okay. The next thing is called its mass number. What about the number of neutrons? How can I figure out what is the number of neutrons? So to figure out number of neutrons, you should know the mass number of an atom. The mass number is basically equal to the number of protons plus the number of neutrons. So mass number is equal to protons plus neutrons. Now, if I know what is the mass number of an atom and I know what is the number of protons, I can figure out what is the number of neutrons. Again, this is also a whole number. This represents the total number of particles that are present in the nucleus. Okay, mass number represents total number of particles in nucleus, which is protons plus neutrons. This is a number that does not appear on periodic table. Okay, so sometimes on periodic table, I'll show you later on, you will see another number that is not the mass number. Okay, mass number, if the question is asking, it will either usually give you the mass number or it will give you the protons and neutrons and will ask you to figure out what is the mass number. Okay, but if the mass number is given to you, you can easily figure out what is the number of neutrons. For instance, in this question, potassium has a mass number of 39 and atomic number of 19. To find the number of neutrons, let's figure out how will we find number of neutrons. So if the mass number is 39, atomic number is 19, what is mass number? I know that mass number is equal to protons plus neutrons. Let's do the solution ourselves. So mass number is 39. 39 is equal to protons is 19 plus the number of neutrons. So in order to solve for neutrons, again I'll do some algebra here. I want to figure out what is the number of neutrons, which means I need n on one side of this equal and everything else on the other side. So I need to move this 19 from here. How can I move that? I can subtract, since 19 is added to n, I'll subtract it on both these sides. So this would be minus 19 and then the right side will also be minus 19. So that would give you this 19 and minus 19 would give you 0 plus n, which is n. So n would be equal to total 20. So number of neutrons here would be 20. So you can do the same thing and figure it out for any particular element in the periodic table. Okay, so for instance, if we are talking about an atom of lead has a mass number of 207, how many protons are present, how many neutrons are present, and how many electrons are present in this atom? How can we do this? I know the mass number is 207. I need the number of atomic number of this element as well. How would you find that? You go to your periodic table. The question is about lead. Lead is Pb. Let's find where Pb is located on periodic table. Pb is right here. Okay, the question was telling me that the mass number of Pb is 207. I know from my periodic table that the atomic number of lead is 82. Again, as I said, atomic number is specific to element, it never changes. So Pb will always be 82. Okay, so you can rest assured it's always going to be 82. So if atomic number is 82, that means this is equal to number of protons. Protons, first thing I know now is protons is 82. Second thing I know that mass number is equal to protons plus neutrons. So 207 is equal to 82 plus neutrons. Now I want to figure out what is number of neutrons. So I have to get rid of 82, which means I'll subtract 82 on both the sides and figure out what is n. So 82 and 82 will turn 0. This side will be, I'm left with n is equal to, this side will give me 1, 2, 5. So neutrons is 125. The last part was what is the number of electrons. Again, PV you see is neutral. So if it is neutral, that means number of electrons will be equal to number of protons, which is equal to 82. So that would be answer to your third question, which is number of electrons. Okay, there are questions like you can see here. So you guys can try and practice those questions by yourself. Moving on, we'll move to go back to our periodic table. The periodic table that you see, the first time it was created by Dmitry Mendeleev, and he basically arranged the elements in the periodic table with increasing atomic mass. So the mass of the atom. And he also arranged the elements into groups, and each group had similar properties. But now we have changed some of the arrangement of the periodic table. The modern periodic table that you are using now, there the elements are arranged according to increasing atomic number and not the mass of the atom. Okay, so previous periodic table that Mendeleev came up with, there the atoms were arranged according to their mass, and now we are arranging it according to its atomic. What do I mean by that? You can see right here. See hydrogen, this hydrogen is repeated right here because remember hydrogen is a non-metal, so usually it falls right here. But to make it look better, we keep hydrogen sometimes here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you see right here, as I'm going down, as I'm going through a period, the atomic number is increasing. So now all these atoms or elements in the periodic table are arranged according to increasing atomic number, which is this number right here up top. Okay. Other thing that you see in a periodic table right here is another number below. See right here under hydrogen it's 1.00791, lithium is 6.941. What is this number? This is called the atomic mass. This is the atomic mass of the atom. This is not the mass number. Okay, there's a big difference between atomic mass and mass number. Mass number essentially means that is equal to protons plus neutrons. Atomic mass is how much weight is it for mass of an atom. Okay? And we'll see how atomic mass is calculated. But to understand that, we have to understand another terminology which is called isotopes. So isotopes, what are isotopes? Isotopes sometimes, most of the times actually, elements consist of multiple isotopes of an atom. And what are isotopes? Isotopes are the atom of the same element that have different mass number. Okay? So sometimes atoms can exist and have different mass numbers, but they will still always have the same atomic number. Okay? So atoms with the same atomic number, this can get sometimes confusing, but atoms will always have the same atomic number but different mass numbers. Okay? Those atoms are called as isotopes. So if they have same atomic number, meaning they will always have the same number of protons, but they will have different number of neutrons. Okay, these are called isotopes. Most of the elements in the periodic table that you see exist as multiple isotopes of an atom. For instance, if we talk about atoms of magnesium, Mg stands for magnesium metal. Magnesium has 3 different isotopes that you can see right here. It is magnesium 1224, magnesium 1225, magnesium 1226. The number that you see right here, 12, is the atomic number. So you can see all these atoms have the same atomic number, and what's different is this number, which is called the mass number, 24, 25, 26. So now if I give you all these 3, what is the difference here? This is the atomic number 12. All of them carry the same number of protons, which is 12. But the number of neutrons is different. For instance, the first one that you see right here, the number of neutrons would be 24 minus 12, which is 12. The second one that you see would be 25 minus 12, which would be 13. And this third one that you see right here, so this is number of neutrons. Neutrons is 24 minus 12, 25 minus 12, and 26 minus 12, which would be 14. So what's different here is number of neutrons. Number of protons is always same, which is 12, 12, 12. So isotopes basically have the same number of protons but a different number of neutrons. And what you saw right there is called the atomic symbol, or the symbol of an atom. So whenever we write the symbol of an atom, it basically consists of the name, which is the symbol of the element. Right here you see example is magnesium. The number that is written as the subscript on the left side is the atomic number, and number that is written as a superscript on the left side is the mass number, always. Okay, so if you're given this symbol, you know this is atomic number, which is equal to number of protons. This right here is the mass number, which is equal to number of protons plus neutrons. And this is a symbol of the element. Okay, for instance, question like this: there are 3 naturally occurring isotopes of carbon, carbon 12, 13, and carbon 14. Write their atomic symbol. Write the atomic symbol for each isotope and state the number of protons, neutrons, and electrons in each of these isotopes. So the question is to figure this out. Now, how can we figure the atomic symbol out? The atomic symbol, first thing I know, is the symbol of the element, which is this, carbon. And what comes at the bottom is the atomic number. What is the atomic number of carbon? For this, you need to go to your periodic table, look for carbon, and once you look for it, you'll see that the atomic number would be 6. The first element that you see right here, the first isotope, is carbon 12. This number 12 that you see is its mass number. So only difference, remember the difference in isotope is their mass number, 12, 13, 14. So the different number that you're seeing is its mass number. Where does the mass number go? Up top. So this would be the first symbol. The second would also be 6 and 13. The third one would be 6 and 14. So this number, atomic number, never changes. So number of protons everywhere would be equal to its atomic number, which is 6, 6, and 6. Number of neutrons here would be 12 minus 6, which would be 6, 13 minus 6, which would be 7, and 14 minus 6, which would be 8. Number of electrons, since all of these are not charged, they are neutral, meaning the number of electrons will be equal to number of protons. So 6, 6, and 6. Only difference here you can see is protons is same, electrons is same, only difference is number of neutrons. Okay, so this is basically called the atomic symbol of an element. Okay. The next question is, consider the following pairs of atoms in which X represents the chemical symbol of an element. So these are the options. Which of the pairs are the isotope of the same element? Assuming X is an element, X represents chemical symbol of an element. The question is asking which of these 3 pairs are the isotopes of same element. How would you know? Isotope would have a different mass number. So if it is X, they would have a different mass number. This number should be different. But this number, which is the atomic number, each time is going to be same, right? So we have to identify 2 pairs where this is same. Nope, not this, not this. This is the one where this is same, 6 and 6, and these 2 are different, which means B is our answer as the pair of isotopes of the same element. And remember, for an element, A never changes, which is the atomic number. Okay. All right, then the last thing is the atomic mass. So like I mentioned, the number that you see in your periodic table written at the very bottom of in each box is called its atomic mass. What is this? So you saw how in isotopes there is an element, let's say one element X, its atomic number is 6, and this was 12, this is X, this is 6, this is 13, right? So both these atoms exist. Now you know that What is the difference here? The mass number, meaning the number of neutrons is different, right? So number of neutrons are very heavy. Neutrons and protons are the ones that give the mass to an atom, which means X12 will weigh different than X13, right? But when the element exists, it would be a composition. It would have a mixture of X12 and X13. So an average mass of X is calculated, and that is called the atomic mass of that particular atom. Okay, so atomic mass by definition is actually the weighted average of all the naturally occurring isotopes of an atom. So if I'm talking about an element X, some of those atoms are X12, some of those atoms are X13. So some weigh like 12, some weigh like 13. And when you take an average of that mass, depending on how much of X12 and how much of X13 is present, you would get an average mass, which is called the atomic mass. So the number that you see at the bottom is the mass of the atom averaged out by averaging the mass of its naturally occurring isotopes. Okay, this is not, remember, this number is not the same as mass number. Mass number is always a whole number, and this would always be given to you or asked in question, but this is not shown on periodic table. Periodic table shows you only atomic mass. Okay, that is the first part of the atoms and elements. The next part will be following up in the next video.